Yo, what's up, guys? So today, we're going to do using C++ to finish this code, which is given a set of n distinct elements. We are going to select k elements from the set and generate all possible permutations of the k elements. Like, given the set 1, 2, 3, 4, and k equal to 2, we can generate all the permutation. And permutation is like the keyword. So permutation means they need to be listed in a specific order, such as ascending, descending, etc. So 1, 2 in this scenario is considered the same as 2, 1. And we will not use 1, 1 because we can only use numbers in this set. And I'm going to show like the one that's already done. But before that, when you do this, I will explain this code step by step. So it's actually pretty easy to do. So simply it's like two parts. Number one, when you find all the subsets of this set, and then we're going to print it only if it had k element in it. Let's start. So first we need to generate the set and doubtfully, and this is how you generate a vector. We'll call this set, and it will equal to 1, 2, 3, 4, and then int k equal to 2. So this will create a vector that's int. This is like the part of the vector declaring the vector, and this is what type of vector it is. So it can also be a char. Int just mean like integer, short for integer, and int main. Oopsie daisy. So we are going to create another vector. We'll call it another vector. This is an integer vector. Will be called. I'm not good at creating names. I'm just going to call it vect, and this will be equal to an empty vector for right now. Then we're going to create this function called subset, and it will need std vector int. We need this vect and index. Actually, I'm not going to use the index right now. I need like make you guys see what will happen if we do not use the index. And we'll just call this function subset, and subset will be we need the vector first, so vect. And now we're going to use recursion. So for int I equal to 0, I less than set dot size I plus plus. So this I dot size is a really important function. So this is the name of the vector, and that size is just this function that's in the library that we included. It basically will tell us how big the vector is. So though like currently there's 4 elements in it, so what it will be is 4. And for int I, and then we will do this thing which is vect dot push back set I. So this pushback function basically would just put the ith set I, just like finding the ith element in the set, and this will put it at the last place of the vect. And then we'll call this function again, which is subset and vect. So now the vector will be the original vector plus I, and then we will do this thing called subset dot pop back. Wait, no, not subset, but vect dot pop. Oopsie, pop. Oh my god, not this. Pop back. I think that's how you do it. I'm pretty sure. And this basically just delete the last element. So I will draw it with my paint. So first, we'll have an empty vector, because that's what we put in, right? It's an empty vector in Delphi. And then we'll start the for loop. So since I start with 0, so vect will be pushed back set I, which is the first one, which is 0. So set 0, it's just 1, which is our first element in the vector. So now it'll be 1. And then, well, before that one, std cout vect std endo. This is just a temporary statement. Oh wait, yeah, I forgot. You cannot just like straight up print a vector. That's not allowed, since vector is like, it's basically a list of a lot of elements, so you cannot just print them out. But we can use this is like the most basic way, I will say. I list them vect size, finding the size, then I plus plus, oopsie, I plus plus. Oh my god, how it's happening. I plus plus. And this is basically the most fundamental way to so this would just, so we use a for loop, and then it will print out the 0th element, first element, second, and third. Keep in mind the 0th element right here, just 1, which is a first. This is how computer interpreted. But like if we do it like this, yeah, it will be like, it will just print down a lot of ones. Why? Let's see. So we will use this. So then it will print out 1, 1, since we used this function, and then we used our function again. So subset, we called it again, and then we will push back set I, which it's, since we restarted, like we used the function again, we restarted the for loop, so it'll be still 1, which is why we need this thing called index. And index, and first we'll give in the value of 0. We give it index I plus 1. Or we can just use I plus plus, but it's easier to interpret it that way. And index. So now we have like actually a way to terminate, which is basically end this function, which is when since we just keep on making the index bigger and bigger, once the index equal to 4, it will end. And let me show you guys what this will. Oh, wait. Oh, yeah, I forgot to. So this is what's happening. It looked really confusing, but now not anymore. So see out std endo. This just basically means every time we print out the vector itself, we'll change the line to the next line. So now it will look like this, which is a really, I would say, better format. So 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 4, and like that. And I will explain to you guys what's happening. Erase it. Alright, let me just erase that whole thing. Yeah. Okay, so now we'll just do this, and like we will start with 1, which we already said, and then now we will just print this one, which is what line 13 to 15 is for. So we printed out the 1, and now we're to go to our next thing. Since after like when it's 1, we declared it again, which is like after the first time we used recursion, so we used the function subset again, and we made the index equal to I plus 1, and at that time I is equal to 1, or 0. Yeah, it should be 0, my fault. So now I will be equal to 1. So after we put index equal to 1, then we will find out that since I will start at index, which is what this thing says, then we need to remember that we need to always keep in mind that when it's 1, it's actually the second element. So now we'll add 2, and then we'll add 3, etc. But when it reaches 4, the fourth time we use the subset function, it will like index will be just like I will just equal to the size, which is 4. So index will just be 4, which is really large. So now we will end the subset function, and we will go back to the last time where we used it. So that basically means line 19 is finished, and we will go back. So it's like I would draw it like this tree diagram thingy. So now we used this 1, and then after this we used 2 and 3 and 4, right? But now the for loop ended, so we will go back to the time where it's 3, like which is here, and this pop back function basically would just like delete the 4, which is like last digit. So it will go back here, and then now it's like it will just, since it will eliminate this, it will just continue this loop, and then it will just become like 1 2 1 3 1 2 3 4. At first like 1 1 2 1 2 3 1 2 3 4, and then it will become 1 2 4. It will skip this one because we need to use the pop back function to make the computer know when to go off to which branch. So in this branch, we're using the 1 2 3 4, and after we use the pop back function, which we eliminated the last element, we will do 1 2, and then we'll start another branch, which is 1 2 4. So this is basically what it means. 1 2 1 2 3 1 2 4 1 3 1 3 4. This is like when you get to like deeper computer science, you will like actually it will be like for a larger recursion, it will be really complicated to think through. So now we generated all the subset. But did we finish? Did we finish? We didn't. Why? Because it says select k elements from it and generate all possible permutation, which means k equal to 2. So we need to generate all the subsets in this this term, like I would say subset, like the subsets that have a length of 2. And try to pause the video and think about how to do that. And I'll give you guys a hint. Use a vect that size. All right, 5 seconds. Pause the video and try to do it yourself. I will show the answer. So it's actually pretty simple. We will just use an if statement, and we will use a vector dot size vect dot size, which is just saying the size of this vect. If it's equal to k, then we will print it out, right? And oh wait, not this. I'm gonna put the std here, so and I just like waste a lot of random lines. And it will indeed be 1 2 1 3 1 4 2 3 2 4 and 3 4. So this is pretty much just the end of it. However, we can still improve this program. So we have 2 homework. One is give a limit to k. Like if k is 5, then there would definitely be an error in this program. So when you have like an if statement to see if it's like greater than the size of the set, then you like print error or something. And if less than 0, it'll also print error. And also we can enhance and shorten this code by putting this statement inside of this statement. Try to think about how to do this. This will be the homework. And thanks for watching. Bye.